Yes, so hopefully let's move on towards our lecture number 16. Okay. Yes, it has started. Okay. So before moving on to lecture number 16, is someone amongst you, if in case is new to the channel, okay, if someone of you is new to the channel na, then go and watch the previous 15 lectures. Okay, someone is new in the channel, then they must go and watch the previous 15 lectures, because it will be in continuation with this. Okay, so you must watch the previous 15 lectures, okay, in order to understand this 16th class better. And the link has been provided in the description also, and the link has also been provided in the form of comments. Okay, so both the things are there. Either way you can have a look at the playlist and can watch from the lecture number 1. Okay, so in the lecture number 16 we are going to discuss this modulus function. Okay, modulus function, this function is very useful, and in one of the PYQs it will be helpful in solving. Okay, so mod of x, it will be minus x when x is smaller than 0, and it will be plus x when x is greater than 0. So students get confused over here. Students get confused over here in this modulus function. Why do they get confused? They get confused that the modulus should open always with a positive sign. The value of mod is always positive, they say like that. The value of mod is always positive, because even if I take 5 mod, it is 5, and even if I take minus 5 modulus, then it is 5. Okay, so in either cases it is yielding you 5. Then how it is minus x over here for x is smaller than 0, and why it is plus x for here for x greater than 0? They ask like that. So first of all, I would like to tell you one thing. Just put just put x equal to minus 5 over here. Just put x equal to minus 5 over here. So as soon as you put x equal to minus 5 over here, it comes like this. Okay, and as it comes like this, minus into minus will eventually become plus, right? Because this condition will hold good for x equal to minus 5, because x is smaller than 0, it implies this condition. So minus into minus will eventually become plus 5. That's why for x is smaller than 0, modulus x opens with a negative sign, and for x greater than 0 it opens with a positive sign. You must have got it now. Okay, so never ever think that mod x will simply mean x, because it is always positive. No, it will mean minus x for x is smaller than 0, and it will mean plus x for x greater than 0. Why? Because for x is smaller than 0, for example, if I take minus 5, then it will come minus 5 over here. We all know this very well, that minus 5 mod is equal to 5. So if I put it in this function, then I must get basically equal to 5. So only minus into minus will yield you plus 5. So that's why modulus function opens with a negative sign for negative integers. Got it? That's why modulus function opens with a negative sign for negative integers, because this minus into minus will become plus eventually, and it will yield you this result, minus 5 mod equal to 5. Now what about positive numbers? It is very straightforward. For positive numbers it will open with 5, so I will put over 5 here, and x is greater than 0 condition will hold, because 5 is greater than 0. So x greater than 0 condition will hold, and this formula will apply. Then plus into 5, that will equal to plus 5 equal to 5. So that's how the positive mod is opened. So never ever think that it is a modulus, so how it is opening with negative sign for x is smaller than 0. Never think like that. Modulus will open with a minus sign for x is smaller than 0, because minus into minus will have to become plus. That's why. Okay, so this is the thing. Now we will move on towards problem, which is UPSC physics optional mains PYQ 2018. Okay, UPSC 2018 physics optional PYQ, and the question number 1 states like this: the wave function of a particle. Okay, the wave function of a particle is given as, the wave function of a particle is given as psi x equal to 1 upon square root of a e to the power mod minus of mod x divided by a. Okay, so this is the wave function of a particle which is given. Okay, this is the wave function of a particle which is given to us, and what you have to find, you have to basically find number a. Okay, number a, the thing which you have to find is find the probability, find the probability of locating, find the probability of locating the particle in the range minus alpha, okay, to plus alpha. Okay, so probability of locating the particle in the range, this you have to find out, number a. Okay, so and the number b part, I will write it later on. Number b part I will write later. So part number a is that the wave function is given like this, and you have to find the probability of locating the particle in the range for x belonging to, that means that x simply lies in the range minus alpha to alpha. Okay, that simply means like this, x belongs to the range minus alpha to alpha. So I can clearly see this thing, that this is one dimensional, right? One dimensional time independent Schrodinger wave equation, one dimensional. I had told you in the previous classes what is one dimensional Schrodinger wave equation, what is three dimensional form, all these things I have already told you. So if you haven't revised the things, it will be difficult for you here. Okay, so it is this is the one dimensional form of Schrodinger wave equation. Now clearly one thing I can say why it is one dimensional, because clearly it is x over here. Okay, if it is three dimensional, then r comes over here. In three dimensional form, r vector comes over here, position vector comes over here. But as x is coming over here, so clearly it is one dimensional form. Okay, it is clearly one dimensional form. So in this one dimensional form, the value of x lies between minus alpha and plus alpha. So you have to find out the probability. Okay, now tell me one thing. In this question, this is one dimensional question, right? One dimensional question. So uh, will triple integral apply? Will triple integral apply or single integral? This is the question number one. Now the simple answer to this is triple integral will not apply. Over here triple integral will not apply. Why will triple integral not apply? Because you clearly know this thing, na? You clearly know this thing, that if you try to apply triple integral, then it is for volume. Triple integral is for volume, right? What is triple integral for? Triple integral is for volume. Okay, but over here our equation is one dimensional. One dimensional means line, not volume, it means line. As it means line, so line is single integral, it is not triple integral. Integral is for volume. This is one dimensional equation, so it is basically line. So it will be basically your single integral is the answer to your question. Okay, so single integral will apply. So I will just draw a diagram. So wave function is given like this, and you have to probably find the probability in this region. So you will basically draw a line like this in order to denote it. So x prime will be here. This is x prime, suppose, and this is your this is your x axis. Okay, you know this very well. And this is the origin of the x axis, right? This is the origin of the x axis. Y and z axis are not present. Why y and z axis are not present? Clearly y and z axis are not present because it is a one dimensional case. As it is a one dimensional case, so only one dimension is present, that is x axis. Along x axis it is present. Y and z will be discarded because it is one dimensional. Okay, so let this be point B, and let this be your point A. Okay, so you have to find the probability between x equal to minus alpha and x equal to plus alpha. Okay, you have to find the probability between these two. Okay, now we have been given the wave function like this. We have been given the wave function like this, that it is 1 upon root a e to the power minus mod x, okay, divided by a. This is given to us. So simply, in order to find the probability, we have to find the probability of locating the particle in this region. We have to find the probability of locating the particle in this region. So in order to do that, we know this very well, that probability will come out to be equal to integration, limits will be minus alpha to plus alpha, okay, and psi star psi, okay, dx will come. This is what? This is basically your normalization condition, right? This is your not normalization condition, but your probability is found like this. I had already told you in the previous classes that for three dimensional space, what was the formula? For three dimensional space, this was the formula, right? Psi star psi d tau, okay, and this was for x, and this was for y, and this was for z. Okay, so triple integral was being taken. Okay, this denotes all space. Okay, for three dimensional, such is the formula, and here d tau is equal to your dx dy dz. Okay, so triple integral holds there in the volume. Okay, but over here it is a line, it will be one dimensional, so y and z integral will be discarded. Over here this y and z will be discarded, so we are left with this. Okay, integration along x psi star psi dx. Okay, we are left with this because the one dimensional case is there, so we are left with this. Now psi value has already been given to us like this. Now I had already told you in the previous classes, that whenever we take the conjugate, we replace the I by minus I. I had already told you in the previous classes, then whenever you take the conjugate of a wave function, the I symbol, iota, is basically replaced by minus I. So iota is replaced by minus I for complex number in order to find its conjugate. Now tell me, over here in this expression which is in the box, does it contain iota term? This expression in the box clearly does not contain any iota term in it. So this expression in the box, as it does not contain any iota term in it, so clearly the modulus, not modulus, the conjugate of it will be equal to this only, because conjugate of a real number, you only tell me na. Okay, let's see over here. Suppose I have this with me. Okay, suppose let us assume hypothetical numbers. Okay, very very hypothetical, a plus ib. Okay, so if I find its conjugate, then it will be equal to a minus ib. Okay, now if suppose I tell this that it is equal to a only, so you replaced over here that I with minus I. But if psi is equal to a only, then psi star will also be equal to a only, because the I term is not at all present in it. So how will you replace I with minus I? Or I can imagine it like this, I into 0. I can imagine it like this, and as soon as I replace I with minus I, so it becomes I into minus 0, I into 0 in the minus form. So anything into 0 is 0, so it will be a. Anything into 0 is 0, so it will be like this, a plus 0 equal to a minus 0 equal to a. So the conjugate of a real number is the same number. So as I term is not at all present over here, so clearly its conjugate will be equal to the same function. Its conjugate is going to be the same function. Okay, no need of any I. Okay, no need of any, there is no I, so psi star and psi are going to be the same. So clearly I will write this integral on the next slide now. Okay, I will write this integral on the next slide now. So when I write that integral on the next slide, clearly I get this thing, that minus alpha to alpha psi star psi dx, that will be equal to your integration minus alpha to alpha, okay, 1 upon uh, 1 upon root a e to the power minus x mod by a, okay, okay, and then again in the place of star, psi star I put this, and in the place of psi again that same thing is going to come, because the conjugate and the original function are the same, right? So the same term is going to come, and eventually it will become like this. And what will happen next? What will happen next? So clearly I can put this a out of here, okay. So 1 upon root a into 1 upon root a will become 1 upon a. So 1 upon a will come out minus alpha to alpha, okay, e to the power minus x mod by a multiplied by e to the power minus x mod by a dx. This will come, okay. Then you will apply the law of indices, okay. What is the law of indices? These powers will be added. According to law of indices, these powers are going to be added. So you will simply add those powers, and it will look something like this: e to the power minus 2 mod x divided by a, okay, and this will be dx, right? Now I have already told you in the starting of the class, okay, I have this is mod x function, right? So I have already told you in the starting of the class, right in this beginning, that mod function opens with minus x for x smaller than 0, and mod function opens with plus x for x greater than 0. So clearly I will break this integral. Clearly I will break this integral into two parts. So let me break this integral into two parts. So if I break this integral into two parts, what will I get? Minus alpha to 0, okay. And for minus alpha to 0, clearly for minus alpha to 0, that is this region, clearly the value of x is negative, okay. So for minus alpha to 0, I will have, what will I have? E to the power minus 2, e to the power minus 2 mod x. Mod x will open with minus x for negative region, okay. So mod x opened for minus x divided by a, okay, dx, okay. And similarly for this thing you will get 0 to alpha, okay, e to the power minus 2 mod x was there, right? But for 0 to alpha, 0 to alpha the situation is like this, that is the positive region, okay. So you will open it with plus x, okay. So divided by a, and this will be dx, okay. And eventually this will close your bracket, okay. So what will happen? It will be like this, something like this: 1 upon a, okay, minus alpha to 0, e to the power 2x, minus into minus will become plus, okay, divided by a dx, plus integration 0 to alpha e to the power minus 2x by a dx, okay. So this is the thing, and after that you will integrate and put the values, okay. So I don't think there is any need to explain such a simple integration. It will be like 1 upon a multiplied by a by 2, okay, e to the power 0, okay. You must keep on doing this along with me. You must keep on doing the integration along with me, okay. I am not going to explain the integration. I think you must have done enough in your school and college exams to learn the integration process. I don't think there is any need to explain those integrations. Those are very very simple ones, okay. So it will yield you 1 upon 2, okay. Then it will be 1 minus e to the power minus 2 alpha divided by a, okay, minus e to the power minus 2 alpha divided by a, right? Plus 1 is there, okay. So then what will happen? 1 upon 2 2 minus 2 e to the power minus 2 alpha by a, right? Then 2 will come out of the bracket, and after 2 will come out of the bracket, it will look something like this, right? So 1 minus e to the power minus 2 alpha by a, this is your probability of finding the particle. Okay, this is the probability of finding the particle in the region minus alpha to plus alpha. This is the probability of finding the particle in that region. So so easily you found out this thing. But someone may still have that pain of integration. So let me write over here that pain also. Let me address that pain also. That you have this thing, right? Let me explain that integration. E to the power. Uh, Let me write over here 0. Okay. Let me write over here 0. Okay. So let us write over here 0. So I will explain this integration first. That how did we integrate? Okay. How did we integrate? That I am telling. So e to the power what is there? 2x by a is there. Okay, 2x by a is there, and dx is again there. Okay, dx is again. So you will basically apply the integration formula. E to the power 2x by a will come. Then you will do d by dx. Okay, 2x by a. Okay, and this will be minus alpha 0. Okay, then again now it is very easy. Okay, then this d by dx of 2 by a x will become 2 by a. What will this become? 2 by a it will become. Okay, so e to the power 2x by a divided by 2 by a it will become. Okay, and you will basically put minus alpha over here, and we will put 0 over here. Okay, then a will go in the numerator. So a by 2 e to the power 2 x by a. Okay, then minus alpha 2 0. Okay, then what will you do? You will basically put the upper limit, that is 0, in the place of x. Okay, you will put 0 in the place of x, then you will put minus alpha in the place of x, and you will write the minus. Okay, you will subtract it. Okay, so that's how. And similarly this integration can also be solved in a similar manner. Okay, so probability of finding the particle in the region minus alpha to plus alpha is this in the box given. Okay, now it is given in the box. Now the thing is that I had already told you in the previous lectures that if you get some expression in the UPSC exam, what is the difference between UPSC exam and your university exam? In the university exam, whenever such a result is obtained in the university exam. Okay, university exam, whenever such a result is obtained in the university exam, you have to simply quit the answer there. In university exam, quit the answer here. But in IAS exam, you must explain it and draw a graph of it. Okay, explain it and draw a graph, because it is possible over here, that's why. And draw a graph. Okay, so if I try to explain it and draw its graph, so clearly the graph will be, it will depend on alpha. Okay, the graph will be, it is what is p? P is a function of alpha, right? P is a function of alpha. So you will draw a graph of p alpha against alpha. Okay, you will draw a graph of p alpha against alpha. Okay, why it is a function of alpha only but not a? Why it is a function of alpha only but not a? Because I had clearly told you this thing, that your alpha can change over here, because alpha value of alpha is equal to x. Okay, so if you keep on changing the alpha, suppose if you take x equal to minus 8 to x equal to plus 8, then your value of alpha will be equal to 8. Okay, so this strip will be broader for x equal to 8, alpha equal to 8. But if I take alpha equal to 2, then this strip will narrow down over here. If I take alpha equal to 1000, then this strip will uh, uh, expand like this. Okay, so basically that's why the thing is that you have to basically you can draw a graph of p alpha against alpha, and whenever you draw certain graphs, you are sure to find this thing, you must have learnt in your JE time how to draw a graph. Okay, so p alpha to alpha, this is basically your 0. Okay, and your relation says that it is 1 minus e to the power minus 2 alpha divided by a. Okay, it is like this, the relation says like this. Okay, then clearly if you try to put p alpha equal to 0, suppose if you put it to equal to 0, then alpha will come out to be something, right? What will alpha come out to be? Alpha will come out to be 0. Okay, so for x equal to 0, now how this p, when p alpha is 0, then your alpha is coming out to be 0. How you can put it ना यार, over here you can put it now वो भी दुख दर्द दूर करना ही पड़ेगा मुझे, ठीक है ना? I will have to do that also for you. Okay, okay, yeah. Okay, so this is basically your p alpha. Now if p alpha is 0, you are drawing a graph, right? Then what will be the value of alpha? We have to find out that, because we are drawing a graph, and in order to draw a graph you must have an x coordinate and a y coordinate. In order to draw a graph you must have both the coordinates, x and y coordinate. So we know that p alpha equal to 0, that means y coordinate we have fixed to 0. Now we have to find out the x coordinate, because y coordinate 0 is there on this entire line. Okay, so we have to fix the x coordinate now. So in order to fix the x coordinate, just put p alpha equal to 0. So your expression will look something like this. Okay, equal to 0. And then what will it look like? E to the power minus 2 alpha by a equal to minus 1. So minus into minus, both the side will, it will cancel out. Okay, and now you know this thing very well, that anything to the power 0 equal to 1. Okay, so is anything to the power 0 equal to 1, so e to the power 0 will be equal to 1. So 2 alpha by a should be equal to 0. So from here you clearly get this thing, that alpha comes out to be equal to 0. So as alpha is coming out to be equal to 0, this point is fixed, one point has been fixed over here. Now after that I look at this expression. This expression clearly looks exponential. This expression clearly looks exponential. So I will put alpha equal to infinity. Okay, alpha equal to infinity means very large number over here. Alpha equal to infinity means very large number over here. So if I put it in this, then clearly I will get p infinity. Okay, what will I get? P alpha is your given to be equal to uh, 1 minus e to the power minus 2 alpha by a, it is given. Okay, so let me put alpha equal to infinity over here. So as soon as I put alpha equal to infinity in this, because now what are we doing? We are fixing alpha and we are finding p alpha. Okay, because we need two fixed points in order to draw a x and y axis graph. In order to draw a graph on coordinate axis, we must know, if you know one coordinate, then we must know another, so that a point is fixed. Okay, so alpha equal to infinity if you put, so simply this expression will turn into p alpha, what is the value we have to find out, and this expression will turn into e to the power minus 2 infinity by a. Okay, now you know this thing very well, that anything to the power anything multiplied by infinity is infinity only. So it will become minus infinity, because 2 by a multiplied by infinity is infinity only. So it will become like this, and then it will become 1, because this term is equal to 0, because e to the power infinity, 1 upon e to the power infinity is equal to 1 upon infinity, and it will be equal to 0. Anything to the power infinity is 0, infinity only. So 1 upon infinity is 0, so this thing has become 1. So clearly at very high values of alpha, this thing will reach a limiting value. This thing will reach a limiting value, and I know this very well, that the graph of exponential function looks like this. Okay, from this graph I came to know, and at the time of IIT JEE you must have learned this thing, that exponential graph looks like this. So it will reach a limiting value 1 for alpha, very large values of alpha, it will reach almost reach 1, but it will not touch it. Okay, it will not touch it. Okay, this line and this line will not touch, but it will reach to almost 1. Okay, for very high values of alpha. Okay, so yeah, this is the thing, and you can describe eventually. Okay, so you have basically described. So So you can write over here that for alpha tending to infinity, p of alpha almost tends to 1. Okay, that implies that the whole x-axis will be covered, right? So almost 1 probability. Now what is the meaning of probability equal to 1? Probability equal to 1 simply means that 100% sure shot it will be find over there only. One probability equal to 1 means 100% the particle will be there only. Now you only tell me, we had a situation like this. Okay, we had a situation like this. Okay, I am explaining that statement in the last. Okay, we had a situation like this. Okay, this is x dash, this is x. Okay, and this is b. Okay, this is x equal to minus alpha, this is 0. Okay, and this is x equal to alpha. Okay, this is a, right? You got it, right? So if I increase the alpha, if I make alpha tending to infinity, then you only tell me that the entire x-axis will be covered, right? Entire x-axis will be covered. Just imagine this line is going up to USA. Suppose alpha is equal to infinity means that this line is suppose going from India up to USA. Suppose up to USA this line is going. Okay, then what will it that imply? That will simply imply that you have taken alpha infinity, and if alpha is infinity, almost entire x-axis is being covered, and is almost entire x-axis is being covered, and our function is one dimension. Okay, our function is one dimensional because we had psi of x. We did not have psi of r. We had psi of x. So it is one dimensional function. So the probability of finding the particle in this on this x-axis will be 100%. Now alpha equal to alpha tending to infinity simply means that you are taking the entire x-axis. As you are taking the entire x-axis, so probability must tend towards 1. So probability must tend towards 1. So the probability of the particle will tend towards 1. And that is the thing which has been written over here. Whole x-axis will be covered to so almost 1 probability, right? So this is the thing. Okay, so that is how is our discussion for today. And in the next class, now there is part B also. This question has part B also, but I think we will discuss that part B later on. Okay, and it is very easy also. That part B is very easy. Okay, let us discuss it right now only. Okay, let us discuss the part B also right now. So the part B of the question says, okay, what does part B of the question say? The part B of the question says that find the value of alpha. Okay, part B says that find the value of alpha. Find the value of alpha so that probability of locating the particle in the above range, in the range minus alpha x alpha, okay, is 0.5. Okay, so we have to find out the probability, so value of alpha, so that probability of locating the particle in the range, we have to locate the particle in this range. So probability of locating the particle in this range is 0.5. We have to find out such a value of alpha. Now clearly we have clearly found out that your p of alpha has clearly come out to be equal to like this: 1 minus e to the power minus 2 alpha by a, it has come out to be. Now you have to find out its p alpha value is already given, that it is equal to 0.5. How it is given? Read over here. Find the value of alpha so that probability of locating the particle in the range is 0.5. Probability of locating the particle, it is given that 0.5. So we will put 0.5 over here. Okay, so after you put 0.5 over there, you clearly get this thing. Okay, and eventually you get minus 2 alpha by a. is equal to 0.5. Okay, so what will it be equal to? Clearly you can see this thing that after you get this, you will take log on both the side. You will take log on both the side. Why? Because you have to find the value of alpha. You have to find the value of alpha, and this alpha is in power. This alpha is in power. So you will take log on both the sides. So simply take log to the base e on both the side. That is ln. So if you take log to the base e on both the side, so clearly ln half. Okay. Now you know this very well that log a to the power b. Okay, what is ln a to the power b? It is b ln a. Okay, this comes in the forward direction. Okay, so this term in the power will come forward. Okay, ln e. Now what is ln e? Ln e is equal to 1. You must have learnt in your lower classes. Okay, 2 to the power minus 1. Okay, 1 by 2 is 2 to the power minus 1, and ln e, what is it equal to? Ln e simply means that it is equal to log to the base e. So it will be equal to 1. So this thing vanishes from here. So clearly minus 2 alpha by a is equal to ln 2 to the power minus 1. Ln 2 to the power minus 1 means minus 1 power will come in the forward direction. So again this, and this plus becomes, it becomes plus. So alpha value, what I got the value of alpha? I got the value of alpha to be equal to a ln 2 over 2. Okay, a ln 2 over 2 I got like this. Okay, so what will be the range of x? So we know this thing na, that x lies between minus alpha to alpha, right? So in order so that probability of the particle, in order to it be equal to 5, if we want the probability of the particle to be equal to 0.5. Okay, if we want the probability of the particle to be equal to 0.5, then clearly the value of alpha should be equal to this. Okay, that means x, where should x lie? X should lie between these. X should lie between these. X should lie between these. Okay, x should lie between these. So x should lie in between these. Okay, so x lies between these. Clearly you got this thing, right? So that's what was asked in the question, right? Find the value of alpha so that probability of finding the particle in the above range is 0.5. So your range is also there, and your probability 0.5 for alpha equal to a ln 2 by 2. Your probability is 0.5. Okay, so this is all for today's class, and this is how the 2018 year PYQ was to be solved. This is how the 2018 year PYQ was to be solved. Okay, and this is the thing. Okay, सो थैंक यू वेरी मच. जय हिंद, जय भारत. अपना ख्याल रखें. टेलीग्राम ज्वाइन नहीं किया है तो कर लें. ओके, आई विल मूव ऑन टू द नेक्स्ट क्वेश्चन इन द नेक्स्ट क्लास. टिल देन, थैंक यू वेरी मच.